Our next objective in this section is to solve a quadratic equation by factoring, if possible. The steps that we're going to follow here are: 1, get our equation in a form where we have ax squared plus bx plus c equals 0. That's the important part. We need to have something equals 0. Next, we'll factor our expression on the left-hand side of the equation if we've got the 0 on the right-hand side. And then we'll apply the zero product property by setting each of those factors equal to 0. So let's begin with this first example, x squared plus 7x equals negative 12. First, notice it is not equal 0, so we will rearrange this by adding 12 to both sides. Now notice I'm just moving this term. So this is x squared plus 7x plus 12 equals 0. Moving that 12 from a minus 12 to a positive 12 on the left-hand side. That's step 1. Next, I need to factor this. And for a review of factoring, see some of the previous section videos. This factors as x plus 3 and x plus 4 equals 0. Now, the zero product property says that if these two things multiply to be 0, then one of them equals 0. So either x plus 3 equals 0 or x plus 4 equals 0, which implies, subtracting 3, that either x equals negative 3 or, subtracting 4 on this side, that x equals minus 4. Those are the solutions to that quadratic equation by factoring. Now on our second example, we don't have to do the first step. This is the first step. It's already in the form of quadratic expression equals 0. So now we'll factor this. And that, because it is just an x squared term, it's not a 2x squared or 3x squared, any of that, we can go ahead and work straight towards this. Let's see, two numbers that multiply to be negative 12 that add to be negative 4. That should be a 2 and a 6. So we have a negative 6 and a positive 2. Now for our zero product property, this means that either x plus 2 equals 0 or x minus 6 equals 0. Now solving those, we see that we're always going to use the opposite operation. So this means that either x equals negative 2 or x equals positive 6. And those are our solutions to that equation. And just like before, we can always plug those back in to check. All right, next two examples. Solve the following quadratic equation by factoring. Now, this one is already in the form, the quadratic expression equals 0. So we can attempt to factor this. And there is not a greatest common factor, so I need two numbers that multiply to be negative 96 that add to be 29. All right, let's see. Negative 96. All right, I need to add to be 29. Okay, looks like 3 and 32 work. We'll have a negative 3 and a positive 32. So I'm going to do the factoring real quick. 12r squared minus 3r plus 32r minus 8 equals 0. So these two have a 3r in common. 4r minus 1. These two have an 8 in common. So plus 8, and that would be 4r minus 1, which means this factors as 4r minus 1 times 3r plus 8. For step 3, 4r minus 1 equals 0, or 3r plus 8 equals 0. Now the expression on the left is going to be adding 1 and then dividing by 4. This will be r equals 1/4. In this expression on the right, r equals, we'll subtract 8 and then divide by 3. So r equals 1/4 or r equals negative 8/3. Now for our next example, we need to first get it to be equal 0. So I'm going to move my 32w term to the left-hand side. Now again, all I'm doing is moving this term, not actually combining any terms. So 4w squared minus 32w equals 0. Now this one does not factor as the others do. It's not a trinomial, but there is a greatest common factor. Greatest common factor is 4w, so that this factors as 4w, and that would be w minus 8 equals 0. So we'll set each of these terms equal 0, equal to 0. Now the expression on the left, dividing by 4, we see that w equals 0. In the expression on the right, we see that w equals positive 8.